let V and W be vector spaces. Of equal finite dimension. So we have two vector spaces with same dimension, and let T be a linear transformation from V into W, be a linear transformation. Then the following statements are equivalent. Then the following statements are equivalent. The first statement is T is 1, 1. The second statement is T is owned. And the third statement is rank of T is equal to dimension of V. So now let's prove them. So what first it means by saying that the few number of statements are equivalent, it means that we are given any of these statements, any of a single statement implies all of the others. So when we have a linear transformation between two finite vector spaces whose dimension is equal, actually between two vector space with equal finite dimension, then if a linear transformation is 1, 1, then it is 1, 1 if and only if it is on to. And if and only if rank of T is equal to dimension of E. So any of these statements are given, we can prove the other two. तो इसी तरह से अगर 4, 5, 6 statements भी दिए होंगे and we are said that they are equivalent statement, that means any of the single statement will imply all of the others. So therefore these three statements imply whenever we have two vector spaces V and W which are finite dimensional and have the equal dimension, that means dimension of V is equal to dimension of W, then once we have T is 1, 1, it means T has to be owned to, and once T is owned, it means T has to satisfy rank of T equal to dimension of V. And once we have any of the three conditions, we can always derive the other two. So any of these three conditions imply all of the three. So now in order to prove that certain number of statements are equivalent, तो हम क्या करते हैं? We always say that, we always prove it like this. First statement implies the second statement. Then we show that second statement should imply the third statement. Then इसी तरह से we show that third statement should imply the fourth statement, and so on. And then we have some, suppose statement number n, then this should lastly imply the first statement, and then again first implies second, second implies third, and so on. तो अगर इस process में suppose अगर हमें करना होगा, suppose how third statement implies not third, let's write some sixth statement. How does it imply suppose second statement? तो इस चीज को प्रूव करने के लिए हम क्या करेंगे? We will prove that 6 implies 7. Now 7 implies 8. Now so on. And up to we will reach the nth statement. Now this nth statement will imply the first statement, and first will then imply the second. That means sixth will imply the second. तो इस तरह से हम कोई भी statement कर सकते हैं. Any of a single statement will imply any of the others, all of the others in fact. So इस चीज को प्रूव करने के लिए अब हमें प्रूव करना होगा first implies second, second implies third, and third implies first. So now let's take up the proof. तो प्रूफ में हम क्या करेंगे? So first assume that to show statement number A implies statement number B. तो इसको हमें प्रूव करने के लिए हमें assume करना होगा T is a 1, 1 mapping. So assume, because we are given statement number 1 and we have to prove that T is owned. Assume T is 1, 1. So once we have T is 1, 1, then nullity of T is equal to 0. Then nullity of T is equal to 0. So thus, by rank nullity theorem, we have dimension of V. We have this. What is rank nullity theorem? We have rank of T plus nullity of T is equal to dimension of V. And this rank nullity theorem now implies that when nullity of T is equal to 0, nut of T is 0. यहाँ पे तो हमें 0 लिखना है. This is just 0, not the set. Set is the null space. So therefore, this implies rank of T is equal to dimension of V. But now here we will use this thing. Now we have two vector space of equal dimension, and dimension of V is equal to dimension of W. So therefore, we can write this is equal to dimension of W. And this statement actually implies as rank of T is equal to dimension of W. So that is. Now what is this rank of T? Rank of T is actually the dimension of range space of T.
Range of.
And this is equal to dimension of W. तो हमें इस इक्वेशन से क्या मिला? हमें मिला dimension of range of T is equal to dimension of W. Now what is this range of T? Range of T, we know it is a subspace of W. ये है ना याद आपको, range of T, it is a subspace of W. ये हमने already किया हुआ है. So once we have range of T is the subspace of W, and this dimension of range of T is equal to dimension of W, doesn't this imply range of T is equal to W? Does it imply range of T is equal to W or not? Imply करता है या नहीं करता है?
Yes, sir. Yes, sir.
So why does it imply? Because we have this W is a vector space, और अगर हम इसमें एक सबस्पेस चूज करेंगे जिसका डायमेंशन W के डायमेंशन के बराबर होगा, so that means हम एक बेसिस रेंज ऑफ T में चूज कर सकते हैं जिसकी कार्डिनलिटी कितनी है, जितनी W के बेसिस की कार्डिनलिटी है. So that means in R of T, we can choose a basis of dimension n. Suppose the dimension of W is equal to n. That means we can find a basis whose cardinality is equal to n from range of T. But since we know that any basis of a vector space, अगर हम कोई different basis बनाएंगे किसी finite dimensional vector space की, तो हर एक basis की cardinality बराबर होती है. और अगर हमारे पास अब finite dimensional vector space होगी, suppose जिसका dimension n के बराबर है, और अगर हम कोई भी linearly independent set choose करेंगे, that linearly independent set will form the basis of that vector space. तो इस तरह से अगर हमें range of T का dimension है dimension of W के बराबर, तो यहाँ से अब हम R of T में एक basis choose कर सकते हैं जिसके कितने elements है? n elements. So therefore in range of T we can construct a basis of cardinality n, but once we have a linearly independent set of cardinality n from the range of T, that means that linearly independent set will completely span W. So that means that basis will also form the basis of W. So in that case, once we have a subspace that has the equal dimension, अगर हमारे पास finite dimensional vector space होगी और उसकी subspace कोई लेंगे लेकिन इन दोनों का dimension बराबर होगा, then that subspace has to be equal to the whole vector space. So therefore we have range of T is equal to W. अब अगर हमारे पास है range of T is equal to W, so doesn't that mean T is on to mapping? So the range of T is equal to W means that every element in W is the image of some element of T. So that means every element in W has a preimage. So this directly implies T is on to. ठीक है? समझ आया आपको यहाँ तक?
Yes, sir.
Okay, now we will prove that now second part. Now to show the statement number B implies statement number C. Now, so here we assume assume t is owned. तो हमें क्या करना है? To show rank of t is equal to dimension of
dimension.
ये
Okay.
हमें दिखाना है. So now since t is owned, thus range of t is equal to w. तो owned का मतलब यही है, range of t is equal to w. ठीक है. So once we have range of t is equal to w, so this implies dimension
Dimension
of range of
of range of
is equal to
is equal to dimension of
dimension of w. Now what should be the next step? What we have to prove? We have to prove
equal to
range of
dimension
equal
of
dimension
v
of v. हाँ, क्या होगा next step?
is equal to dimension of v given
Exactly.
condition
This is equal to
dimension.
dimension of v. So therefore, this implies rank of t is equal to dimension of v. ठीक है. Now lastly to show statement number C implies statement number A. Now here we are given that rank of T is equal to dimension of V by rank nullity theorem. What we have by rank nullity theorem? By rank nullity theorem, we have rank of T plus nullity of T is equal to dimension of V. So does now since rank of T is equal to dimension of V, so when we cancel out these two terms and both are finite dimensional, so this implies
of t equal to 0
nullity,
nullity of t
and nullity of T is 0 if and only if
t of 1
तो ये हमें प्रूव करना था T is 1. ठीक है. तो समझ आया आपको ये?
Yes, sir.
Okay, now we will take up one exercise. आपको मैंने नोट्स कल भेजे थे, तो ये चीज वहां पे शायद प्रूफ लिखा था इसका भी. ये प्रूफ लिखा था ना वहां पे?
yes sir
जी सर.
ओके ठीक है. नाउ लेट्स टेक वन एक्सरसाइज. तो एक एक्सरसाइज नोट्स भी प्रूव की गई है, लेकिन हम थोड़ी सी डिफरेंट लेंगे. देन यू विल ट्राई टू अंडरस्टैंड द वन विच इज़ गिवन ऑन द नोट्स योरसेल्फ, और उसके बाद हम एक यहाँ पे असाइनमेंट भी रखेंगे जो आप फिर खुद घर पे ट्राई करेंगे. सो नाउ लेट्स टेक एन एक्सरसाइज. नाउ क्वेश्चन. नाउ एज वी नो दैट, सो लेट्स राइट दिस नोट जो हमने इससे पहले भी लिखा. A linear transformation is completely determined by its action on the basis of the domain vector space. Now the question is, find a linear transformation T from, suppose, R4 into R3. Let's write R4 again. चलिए R5 लिखते हैं. Determine a linear transformation T from R4 into R5 which satisfies, चलिए ये 4 थोड़ा ज़्यादा बड़ा हो जाएगा. Let's write 3 here. Which satisfies T of, suppose, 1 to 1 is equal to 1, 0, 1. T of 2 1 2 is equal to minus 1 0. चलिए minus 1 0.
Are you sure, sir?
अच्छा और 5 में हमें डिफाइन करना है, चलो अच्छी बात है. दिस 1 0, चलिए 1 1 लिखते, हो गई 5. सपोज minus 1 1 0 1 0, and then t of 2 2 1. This equal suppose 1 2 1 2 1. ठीक है. Now, actually, we have to find this linear transformation which satisfies these things. So, hence find t of 1 2 3. तो हमारे पास क्वेश्चन क्या है? The question is, we have a linear transformation t from R3 into R5, which sends the vector 1 2 1 into this vector of R5, sends 2 1 2 into this vector, and sends 2 2 1 into this vector. So actually we have a linear transformation and we are given just 3 images of 3 vectors from R3. R3 से हमारे पास 3 vectors है और उनकी images हमें दी हुई है. We have to find the whole linear transformation. हमें सारी linear transformation निकालनी है, and then to find the value of t of 1 2 3. तो इस चीज को करने के लिए हम क्या करेंगे? We will use this statement that linear transformation is completely determined by its action on the basis of V. Now let's look at these vectors 1 2 1 2 1 2 and 2 2 1. Now first we will look at these 3 vectors and they actually form the basis of R3. Actually I know the matrix, जहाँ इस matrix से मैंने choose किया, these 3 vectors form the basis of R3. So first, but we have to verify it first. So in the solution, so here, so let V1 is equal to 1 2 1, V2 is equal to 2 1 2, and V3 is equal to 2 2 1. Then we will first see that whether these vectors are linearly independent or linearly dependent. If these vectors were linearly independent, then we can easily find this linear transformation. फिर हमें कुछ और ज़्यादा वो स्टडी करने की ज़रूरत नहीं पड़ेगी. लेकिन अगर किसी केस में ये वेक्टर्स हमें लीनियरली डिपेंडेंट मिले, तो उस केस में हम क्या करेंगे, वो एक्सरसाइज हम बाद में लेंगे. So first we will check whether these vectors are linearly dependent or linearly independent. तो उसको चेक करने के लिए हम क्या करेंगे? So as we know by the definition of the linear dependence and linear independence, if we have any 3 vectors v1, v2, and suppose v3, to check whether these are linearly dependent or independent, we first choose some scalars, suppose alpha, beta, and gamma. Then write down this linear combination alpha v1 plus beta v2 plus gamma v3. This is equal to 0. तो इस इक्वेशन से अगर हमें मिला अल्फा इक्वल 0, बीटा इक्वल 0, गामा इक्वल 0, what we will get? We will get that the vectors are linearly independent. लेकिन अगर हमें कोई भी यहाँ पे अल्फा बीटा गामा नॉन जीरो मिला, then these vectors must be linearly dependent. So now let's write down this linear combination of these 3 vectors to check whether they are dependent or independent. उसके बाद once we finish that exercise, उसके बाद हम आपको मतलब हम कुछ ऐसा करेंगे जिससे हमें ये ज़्यादा कैलकुलेशन नहीं करनी पड़ेगी, and we can quickly determine whether a given set of vectors is dependent or independent. लेकिन पहले हम इस exercise को इस तरह से करेंगे. So now let alpha, beta, gamma belong to the scalar field A, and consider alpha v1 plus beta v2 plus gamma v3 is equal to 0. So this gives us, now substitute the value of alpha v1, v2, and v3. Now this alpha times v1 is equal to 1 2 1 plus beta. Now v2 was equal to 2, 1, 2. Then plus gamma. And gamma is equal to 2, 1. This is equal to 0. तो यहाँ से असल में हमें क्या मिलेगा? And this gives, now first coordinate is alpha plus 2 beta plus 2 gamma. So it's alpha plus 2 beta plus 2 gamma. The first coordinate. Second is 2 alpha plus beta plus 2 gamma. And the third coordinate is alpha plus 2 beta plus gamma. Now this should be actually, we should write this is equal to 0, 0, 0. Now this is 0, 0. तो इस तरह से हमें ये coordinate vector मिला. This is equal to 0, 0, 0, because we want to find out whether these three vectors v1, v2, v3 are linearly dependent or linearly independent. तो उस चीज के लिए हमें क्या करना होगा? We will have to check this linear combination and find out the possible values for this alpha, beta, and gamma. Now keeping in mind that if we get alpha, beta, gamma all equal to 0, then they are independent, otherwise they are dependent. Now comparing these two coordinate vectors. Now we know that two coordinate vectors are equal if and only if their corresponding coordinates are equal. So this equation implies us alpha plus 2 beta plus 2 gamma. This is equal to 0. And second is 2 alpha plus beta plus 2 gamma. This is equal to 0. And the third one is alpha plus 2 beta plus gamma is equal to 0. Now when we look at these three equations, तो आपको immediately कुछ ज़हन में आता है what is these three equations represented?
Homogeneous.
These are the linear, this is the linear homogeneous system of equations. So which is the linear homogeneous system. अब इन वेक्टर्स को v1, v2, v3 इनको linearly dependent और independent दिखाने के लिए हमें क्या करना होगा? We will just have to verify whether we can find non-zero, whether we can find alpha, beta, gamma to be non-zero, whether this equation has a non-zero solution or it does not have a non-zero solution. तो इससे हमें अब ये सिस्टम मिला. तो अगर हमें इस सिस्टम का कोई non-zero solution मिलेगा, that means these v1, v2, v3 are linearly dependent. लेकिन अगर हमें इस सिस्टम का सिर्फ जीरो सॉल्यूशन मिला, that means these v1, v2, v3 independent. तो अब हमें ये नहीं चाहिए कि इसका सॉल्यूशन है क्या, हमें सिर्फ इतना चाहिए कि इसका सॉल्यूशन नॉन जीरो है या इसका सिर्फ जीरो सॉल्यूशन है. दैट इज द ओनली थिंग दैट वी रिक्वायर. हमें अल्फा, बीटा, गामा का एग्जैक्ट वैल्यू यहाँ पे नहीं चाहिए टू डिटरमाइन द डिपेंडेंस और द इंडिपेंडेंस ऑफ v1, v2, v3. हमें सिर्फ इतना चाहिए, कैन वी फाइंड अल्फा, बीटा, गामा टू बी नॉन जीरो और दे आर ऑलवेज जीरो. हमें सिर्फ इतना चीज देखना है कि ये जीरो सोल्यूशन हमें यहाँ पे मिलेगा या हमें नॉन जीरो सोल्यूशन भी मिलेगा. हमें सोल्यूशन पूरा नहीं चाहिए. तो अब हम किस तरह से निकालेंगे? हम पूरा सोल्यूशन भी अगर निकालेंगे उसमें ज्यादा मसला नहीं है, लेकिन हमें सोल्यूशन नहीं चाहिए. हमें सिर्फ चाहिए यहाँ पे नॉन जीरो सोल्यूशन है या नहीं है, बस इतना ही हमें चाहिए. सो हाउ वी विल डिटरमाइन whether this homogeneous system has a zero solution or a non-zero solution?
Matrix form.
तो इसको हम लिखेंगे matrix form exactly. So we put this system. So this is equivalent to suppose A x is equal to 0.
Equal to 0.
Matrix A. What is this matrix A?
1, 2, 2, 1, 2, 2,
1, 2, 1, 2, 1, 2, 2, 2, 1.
Yes, sir. Alpha, beta, gamma.
Oh, so why this is equal to this? Then the system has a non-zero solution. Has a non-zero solution if and only
determine
if and only if determinant of A is equal to 0. या अगर
Equal to
मतलब rank भी हम कहेंगे rank of A should
Rank
be
less than 3.
number of
Yes.
variables. So therefore, what we have to evaluate? We have to evaluate the determinant of A. Now, determinant of A is equal to determinant of 1, 2, 2, 2, 1, 2, 1, 2, 1. Now, what is the determinant of देखिए किसके बराबर है ये?
1 into 1 to 1 minus 4
minus 2
minus
2 minus 2 plus
plus
2
2 into 2 minus 4 minus
ये वाला 0 है. This is minus 3 and this is plus 6.
plus 6.
So this is equal to 3, which is not equal to 0. Thus, the only solution of Ax equal to 0 is
X is equal to 0.
क्योंकि यहाँ पे हमें ये मैट्रिक्स जो है ये इन्वर्टेबल मैट्रिक्स हमें मिली. तो अगर हम इस इक्वेशन को मल्टीप्लाई करेंगे A इनवर्स से, what we will get? X
X equal to 0.
So therefore, thus alpha is equal to beta is equal to gamma is equal to 0. So thus the set V1, V2, V3, this forms a basis of R3.